Hello there.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
Good evening and welcome everybody, this is Obi-Wan Pez for in Simplex Vachenko. We are going to be doing some math tonight, but just real quick, we do have our 2025 Twitch recap. So, we'll go through the streamer one here. We did a total of 670 hours streamed, with 188 total streams. That includes both our Monday, Wednesday math nights and the, usually it was just like Tuesday, Friday, game nights, but we expanded a little bit, so Sunday, Tuesday, Friday for some of it, and additional days when we felt like it. Distinct days on which we streamed was 178. I guess technically 10 of those were probably some sort of quit to desktop or whatever. Total number of hours watched 2,488. Thank you everybody for hanging out and being a part of chat. I will admit that my Obi-Wan Pez account does account for probably a quarter of that, but you know. Because it's pretty close to 670, because, you know, I'm always here. Top categories: Math, Against the Storm, Elite Dangerous, Satisfactory, and Lorelei and the Laser Eyes were the ones that dominated our hours for this year. Interestingly, we are top 10% in all of those. Somehow. Or, we cannot possibly be top 10% of Elite Dangerous. I can understand Against the Storm, Lorelei and the Laser Eyes, and definitely the math category. Satisfactory is an interesting one for me. I guess just because I, like, devoted an entire day to it for months. And Elite Dangerous, that's weird. I don't know, I guess there's a lot of people who must just play it and then get out. Maybe I'll take a look at that later. Poke. Like, I know a lot of streamers who do Elite Dangerous almost exclusively. So, like I said, it's a little weird. But if there's a lot of people who just get in, get out, then I can understand it. Top stream had 74 viewers. I'm sure that was some ridiculous raid that came in. Probably either, let's see, who would have come in? Astroneer, System Era Softworks, SES, did have a large raid at some point, although I don't know if that was this year. And there was some other, I think, developer stream that also dropped into our stuff at some point this year. Top tags: Teacher, Math, and Maths. 11,197 chats received. So, again, thank you so much for that. Not all of them were me. Top channel emotes. I believe these are used inside of our channel. Many of them used by me. So, you know, it's okay. Biggest fans, obviously myself, because I'm literally here all the time. Math Dork, E to the 2i Pi, Seth G. Stewart, Famished, Don Factorial, Danny Highway, Patrick Crusader, and Phobos Dream had the largest amount of engagement, I think, over the year. So, congratulations and thank you to everybody. We have done 7 stream togethers with Ian Stuckey, Talos Teaches, Don Factorial. Zach is not in there for some reason, and I don't know if we just didn't do an official stream together at some, for the Peter Lillydahl one, or what. We have received 46 raids. Awesome, and thank you, everybody. 12 from Zach, 12 from Don, and 12 from Academy of Useless Ideas. Thank you, everybody, again. And we have sent out 181 raids out of the 188 streams we've had. So, maybe only 7 quit to desktops. Whom did we raid? 29 to Actual Education, because on Mondays and Wednesdays, we do tend to raid math channels. So, if somebody's doing math, might as well. Rhaekodactylus, 8 raids, and Muhoodle, 7. Lately, we have not been up late enough to raid Muhoodles many times, so good times. 5 clips made, 3 unique clippers. Again, I'm one of them, so I might in fact be 2 of them. Top viewed featured clip. Always announce your hubris. Elite Dangerous. Oh, we didn't just... Okay, yeah. This is where you learn how to do step-down training. Ah. Whoops. Shields down. Always fun. Hype Happenings, 224 new followers. So awesome, everybody. Thank you so much for coming. New subscribers over the year is 7. Now we have to talk about this next number. I don't believe that I have raised this much money for charity. We did one campaign, which was Go Tell, and we raised $50, of which I believe all of it was actually my own money. So our goal was $250, and I just threw in $50 because I wanted to make sure that we had some. But for some reason, I don't understand this, because that's not physically possible. So if anybody has an explanation for me, please drop it below in the comments. Because, like I said, I don't know how that is possible. Unless somebody took... unless somebody took my, QR code for GoTel and, did a campaign separately. Or took my GoTel thing and waited until it was done and then threw a bunch of money in. Or what? I don't understand where this came from. It could also be that this is how much we raised as a team for a particular charity, but why would it be on my recap if that was the case? Points spent in your channel, 412,000 points. Thank you for using those channel points. Most of them are probably me, again. And we get our chat badge for 2025. Good times. Yep, so that is our streamer account. Now, I will say that the viewer account is actually much more amusing. Yep, sorry, flashbang. Asterisk. Hours watched, 14,000 hours. So look, I have also opened up many tabs and kept them all running while I went to bed. and work and stuff like that last year. Distinct days visited, 355. Top categories of watching: Elite Dangerous, Science and Tech, Just Chatting, Math, Retro. Favorite streamers are mostly Elite Dangerous. Well, I wouldn't say mostly, I guess. Two Elite Dangerous type people, Rain Man and Fiery Toad. Astro Canuck is obviously our astrophysics friend, astrophotography. Moohoodles does a lot of SciComm as well as gaming, and Science, Balint, and Lita do mostly SciComm stuff. So also trying to help them all out with Partner and Partner Plus and all that stuff. Good times. 19,000 chats spent. Usage of email, or usage of emotes. Yeah, JCM Metal. Jason Charles Miller has a great emote here, and yeah, we definitely spam that pretty much anywhere we go. It's almost always 3 at a time. So, followed by our Obi Lol, followed by Obi Stare, and then Obi Shocked and Yikes are also some fun ones that we use. Yeah, given a few things here and there. Mod of the year. 274 chats sent as a mod in must be Zach's channel, I guess. 18 clips were made, including this one here from Michelle Boyd. She intentionally was making her Khajiit in Oblivion a bit derpy. So and there we go. Right, and the community one is literally everybody, so like there's nothing there that's really all that interesting to me. So I don't know anybody. Okay. So we minicam. I want math night. We're going to get into Solids of Revolution tonight. So we did talk last time about how to find areas of complex figures that have mostly like pieces that are polar in nature. So when we can use polar calculus in order to figure out the areas of circles or polar figures, then it becomes kind of trivial to just be able to find cut pieces. So anything where these overlap each other, we'll be able to find out their areas. This is not a particularly trivial problem. It is difficult to work with, but generally speaking, if you can excuse me. Oh, they've changed it. Don't like that. Why does it have to change? Okay. When we're talking about solids of revolution, and usually we can even just call them revolved solids. What we're looking at here is a particular function is going to be revolved around a particular line of symmetry, essentially. And then what we have here is that this is going to get revolved around this particular line, create this figure, whatever it might be. Okay, now what we're going to look at in this particular case is the fact that all of these individual shapes that we're going to create with volumes of revolved solids is that these are always going to have cross sections which are circles. So every single time that we're doing revolved solids, we're just going to have circular cross sections. Why? Because it's been revolved around this particular axis, so the outer edge of it will always remain the exact same distance away from that axis. Now, my drawing is terrible. It's not going to be particularly perfect. It is not going to actually be symmetric around that line. It will be symmetric around a line. We can find that easily enough. Right, if we go back to our old standby in the other pre-calculus stuff, right, we're going to call this a vertical shift that's been moved to this particular location, y equals d. For the most part, we're going to use the axes and not worry about any particular shifts. Then we'll worry about a particular shift a little bit later. Okay, what is important though is that we note that this is going to have an area which is going to be based on this particular distance which is then going to be defined anywhere along its outer edge as f of x. So whatever function it is, r equals f of x is going to be, not quite, f of x minus d, because this is our 0 point. Okay, so I had a caveat. Right, in this case, r is equal to f of x, and that is guaranteed. So, start here, and we have a function that does something like this. All right, then we could pretend that these are actually the same. Something like that. Okay, so our f of x is going to be that particular distance, and then again we draw a circle that uses f of x as its radius. And then we say the area of any one particular slice is going to be equal to pi times r, which is f of x squared. Okay, and then we want to find the volume of a particular cylindrical piece. So the volume of any one cylindrical piece is just going to be pi times f of x parentheses squared times the distance across that we get here, which again is going to be just delta x. It will always be delta x. We just determine how large we want delta x to be in order to minimize the error. And then we'll need to find the volume of the entire solid, so we need to sum up all possible v sub I as I goes from 1 to n. And again, this is now pi times f of x squared, f of x sub I. And then delta x sub I, which, again, delta x could always be the same, in which case you just take it out as a constant, or it could be different for every single slice that we're taking, so we just call it delta x sub I. And yeah, that's how we're going to get our total volume overall. So, you may be able to see where we're going with this. And if you've taken calculus for sufficiently long, I really hope so. Because if we decide to now take our summation as I goes from 1 to n of v sub I, and then take the limit as n goes to infinity, meaning that we start counting a larger and larger and larger number of slices, delta x correspondingly becomes smaller and smaller and smaller. Eventually delta x goes to 0, and as n goes to infinity. Okay, so then this means we get the limit as n goes to infinity of I going from 1 to n of pi times f of x sub I squared times delta x sub I. Again, it doesn't particularly matter. But nonetheless, because this is doing all of that, this is going to be equal to the integral from a to b. In this case, a is down here, b is down here. Integral of from a to b of pi times f of x squared dx. So our delta x is going to 0. It becomes dx in the infinitesimal. Right? In the limiting case, we have pi as a constant, and we have a and b as our limits of integration. So let's guess that's the volume total. Right, and naturally, if we go the other way, and I mean, quite literally, right? If we go this way around, and then we do the same sort of deal where we say that this is now going to be the distance that we're using. This could be g, but g in this case is going to be a function of y. So depending on where we are in the y direction, it's going to get us a specific x value, a specific x distance, right, equals our x value, which is going to be equal to our r value. And then we take this and draw out again. What's the circle look like? And then make it into a cylinder. The height is going to be delta y. The, again, radius ends up being the g of y, or x, or r. And then again, our individual volume is going to be equal to pi times r, which is now g of y sub I, parentheses, pi times r squared, times now our delta y, or delta y sub I. And again, in the limit, n goes to infinity, of I going from 1 to n of pi g of y sub I squared times delta y sub I is going to use the definition of integration to say that v is going to be equal to integral as we go from a to b, or if you want to call it c to d or anything else like that, pi times g of y squared times dy. Appear to have left my water downstairs. Curses. So whichever model we're using here, here's our A, here's our B. Whichever model we're using, right, we're still using the same limits of integration, just lowermost to highermost. We're still using the function which represents the radius, in this case g of y or f of x. And then we're using a delta variable to indicate indicate which variable it is we're using to integrate over. Okay, so This is also what's known as the disk method, because we use a series of disks to take the volume. So little cylinders or disks are going to eventually, right, populate the entire solid, and then we'll be able to tell what its total volume is by finding all of the individual volumes using integration. The washer method is much the same, but what we're going to do is, let's just literally copy this one over. Right, what happens in the washer method is ever so slightly different, because we're not creating just the same disks that we did over there. We're creating washers. Well, what does that mean? Somewhere we can find another function. Doesn't necessarily matter if it's like a regular cylinder, or maybe if it flanges out toward the end here, on which we're going to say that this is g of y, and this one in here is h of y. Right, what we need to do for the washer method is to find this distance here. Okay, the width is still going to be delta y, just like in the other case. However, the length of this thing is now not going to be to the axis itself. It's going to go from one function to the other. So we have effectively, right, separated out the stuff that makes up the value of h of y, and we're just taking that away. So we want this to be g of y minus h of y. Okay. So we've got this pi times our radius, which is g of y sub I. Okay, so pi r squared minus pi r squared h of y sub I parentheses squared and again take all of this. Right, that's our area for these individual circles. Multiply by delta y, or delta y sub I. All right, give me 1 minute real quick.
Ready to upgrade your phone but your wallet's feeling a little light? Hit up Sex and score the sickest deals on the latest models. Whether you're repping iPhone or Android with an awesome 5-year warranty, Sex has your back, dude. So don't wait. Swing by a Sex store and upgrade your phone for less today. Sex. Stores nationwide. Online at webuy.com or just search CEX. Game on!
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
Standing, staying still, never said what I feel, and every time I took the blame, carried all this quiet shame, 'cause all the pressure in my chest, I've gotta fight to catch my breath, when every step still feels the
Well, yep, he was right behind me the whole time. Good times. Alright, so anybody who is a student of Calculus 2, at least in the States, I don't know what it is for anybody else, but if you were at this level where you were doing volumes of revolution, excuse me, solids of revolution, and you're trying to find the volumes of these things, I would recommend that you draw in exactly what's going on with this particular situation in order to understand better what's happening. Right, so make the individual case show that you know how to take a slice out of this thing, whatever it might be. Then show the limiting case as n goes to infinity. You're taking the sum of all v sub i's as I goes from 1 to n, which is the limit n goes to infinity of the sum as I goes from 1 to n of this pi times the quantity, parentheses, g of y sub I squared minus h of y sub I squared times delta y sub I. And again, when you do that, you end up with the total. Again, volume is going to be the integral going from a to b of pi times the quantity g sub y squared minus h of y squared dy. Okay, so when we get this, then we're going to say that our our volume here, again, this is a washer method. Your slice is again taken as a cylinder that has a hole in the middle. And in this case, it's not really likely you can see the bottom, but in some cases you can, in fact. Right, see through the washer, see the table or whatever through the middle. So you get something that looks like this. Something like that. So, if we end up taking one that says find the volume of the solid of revolution generated by the portion of the curve y equals x squared from 1 to 2 right, so 1 1 2 4 0 0 1 1 to 2 4 almost 0 0 1 2 4. All right, something that looks like this. rotated around the x-axis. So we have something like this, and then this is going to be pulled around like this. Oops. Alright, that's around the back. Alright, looks like the bell of a trumpet, or yeah, some sort of frustrum-like object, right? It is sort of a truncated cone, but in this case it's not a cone so much as a curved cone-like object. Alright, so since this is solid, there's no hole here, this is going to use the disc method, which again, all that means really is that we're just not having to consider a special case. We don't have to worry about what happens when we have a hole in the middle. And in fact, right, we only want 1/2 of this. Radius is going to be equal to the function at any particular x value. And then d, or delta x, is going to be the distance across. Da, 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 da. Don't listen to that. Not really, it just gets flagged for copyright. It's fine. It's fine. Okay. So with that, since there's no hole, we're using the disc method. So what does that mean? Again, all we're really doing is we're saying, okay, we're going to make a disc, a cylinder that's going across like this, which has, again, individual volumes, which are going to be pi r sub I squared times height sub I if you really feel like it. Okay, what's that going to be? We got pi. R is, again, f of x. So f of x sub I squared times the height for any individual one of these. The height of the disk is going across. That's going to be our delta x, or delta x sub I. Then we take the, well, we take the sum of all of them first. But since I know where this is going, right? I goes from 1 to n, and we're taking the limit as n goes to infinity of pi times f of x sub I squared times delta x sub I. Okay, and then what does that do for us? Well, again, this is the definition of an integral from a to b. And you could decide whether you want the pi, because it's a constant, be inside, be outside, do whatever. Anything with the sub i's must stay within the summation. So in this case, f of x parentheses squared dx. So in this particular case, No Copyright Sounds also just changed their playlist today, or 2 days ago, I guess. And there's like nothing on it anymore. It's 45 songs, so it's like 2 hours, 2.5 hours, something like that. It's a little wild. I don't know what's going on. Okay, this is going to get us pi times the integral. We're going from 1 to 2. Hey, Slayer Darth. We're doing alright. How about you? F of x, in this case, is the parabola y equals x squared, which then we're squaring. Dx. Brushing up on stats, probability. Nice. Got any questions? Okay, so our volume for this, the total volume of all of it, is going to be equal to pi times. This is x to the 4th dx, so we need a 5x to the 4th dx in order to have what we need for a direct antiderivative. So if we want to just do antiderivative, you got to make sure you have all the parts. It's just a derivative, and then you say, oh look, I have the derivative of the equation, or the expression, x to the 5th. Right, so then we're going to go, okay, well this is x to the 5th, but we can't just create the 5 out of nowhere. It has to come from somewhere, so we have to also, on balance, have a 1/5. No questions so far. Nice. Ew, memorization. Gross. Well, I will say, you have come to the right place for coin toss / dice rolling, because it's in my name. If you wanted a multinomial distribution, then you can use whatever, either dice or coins or whatever you want to describe what's happening in each of these cases. And those multinomial probabilities come from an nth dimensional simplex right down there. Come from an nth dimensional simplex, which is based upon the number of either sides or values that you possibly could get. So, yeah, you've definitely come to the right place. It's like, man, I just put that down. Alright, so we get this integral. It's going to be 1/5 of 5x to the 4th dx is a direct antiderivative of 1/5 x to the 5th. And then we could also say that normally this is like plus c, but if we're evaluating over limits of integration, then we're going to end up doing like, 1/5 x to the 5th plus c evaluated at 2 minus 1/5 x to the 5th plus c evaluated at 1. So the c's end up just going away. So with a definite integral, it's not needed. With an indefinite integral, we do need that because it could be any of the family of equations that we get. Okay, so v is going to be equal to, this is going to be pi over 5 times the quantity, and we could do this inside the parentheses here because this, pi over 5 stuff is just a constant, so it kicks out. It's going to be present in both terms. So x to the 5th evaluated at 2 is going to be 2 to the 5th, minus x to the 5th evaluated at 1 is going to be 1 to the 5th. So here, this is going to be 32, this is minus 1, so 31. V is going to be 31 pi on 5. And that's cubic units. Use some aspects of stats more than others. Yes, definitely. It is helpful to know the other stuff just for everyday things, especially when you start talking about, like, trying to make sure that numbers are valid. Information that's coming to you is reasonable and not, like, just made up. Who would do such a thing? I never in my life could have foreseen needing to know stats on a daily basis. So, 31 pi on 5. Yep, cool. And I'll post the next one, and if anybody wants to work along, feel free. I will be back. Ads are going to start in 2 minutes, so let's get this posted. Find the volume of the solid of revolution generated by the region bounded by the curve x equals y squared plus 3 and x equals 4y. X equals 4y is 1/4. Something like this. Lol. It's probably not that gentle either. Good enough. Rotated around the y-axis. So here and here, it's going to be rotated around like that. Something like that. Right, now normally this would also include the one that's going out on the negative side, but we're not going to need that in this particular case. So we can just safely ignore it. Mutually exclusive and event independence. Yeah. I'll think about that. Curses. Yep. Be right back. Ads are going to play for 3 minutes.
Yo, ready to upgrade your phone but your wallet's feeling a little light? Hit up Saks and score the sickest deals on the latest models. Whether you're repping iPhone or Android with an awesome 5-year warranty, Sex has your back, dude. So don't wait. Swing by a Sex store and upgrade your phone for less today. Sex. Stores nationwide. Online at webuy.com or just search CEX. Game on!
Finishing that big spreadsheet for work. Retiling the bathroom. It's Christmas. You can sack off all that other stuff till the new year. Recording this Pepsi radio ad sounds like a January problem too. Everything else can wait. It's Christmas after all. Laters! Where's the party at? Pepsi Max, thirsty for more.
I wanna feel alone tonight. 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 I wanna feel
Okay, so we're back. So I found a thing. I found an article by statology.org. Which actually does literally say, what is independence versus mutual exclusivity? Think of the concepts like two different types of relationships between people. Independence is like two strangers who live their lives without affecting each other. So like, there are people in my very town right now whose life is completely independent of mine, meaning we will both live our lives and like, we might not even know the same second or third like groups of people. We probably have like second or third people who are the same, but it's possible that we might not ever interact with each other directly or even have the same friend. And like our lives never actually affect each other. Mutual exclusivity is like two people who could never be in the same room together. Nice. Right? Two events are independent when the occurrence of one doesn't affect the probability of the other at all. So getting more likes on your post does not influence whether it's raining outside. Whether it's raining outside doesn't affect how many likes your latest post gets. Mutual exclusivity, on the other hand, you cannot be both sitting and standing at the same time. Right. So, in the case of mutual exclusivity, you're talking about typically the probabilities of those events will sum to 1. Because they can't all happen at the same time, or like none of them can happen at the same time. So I don't even think it has anything to do with conditional probabilities. I'm saying like the probability of you flipping, you know, a certain number of heads out of 12 flips, right? The sum of all of the individual probabilities has to be 1, because you can only have one particular case occurring. So, in the case of flipping coins, right? Oops, oh dear. Oh dear.
Sorry, we can't hear you.
Advertising on Spotify can help your business turn up
Let's say you're flipping let's say you're rolling a 4-sided die, right? So common D4 from D&D. Right, so you've got probability of 1, probability of 2, probability of 3, and probability of 4. Now, I'm not going to insist that they are all the same. So the probabilities of any one of them occurring could be different from each other. We're not going to make any judgment on that. So what we're going to say is this is going to be, let's just call it little p1, little p2, little p3, and little p4 as their probabilities. So what are the possibilities that we have? Well, if we have no flips, then there is only one possibility. We have nothing. Easy enough. let's see, 0 flips, right? One possibility, you got nothing. If there is one flip or roll, we're not doing coins, we're doing flips. No, we're doing rolls. Jeez. Then, there is either the case that you land on the number 1, the number 2, the number 3, or the number 4. Right? This looks terrible, but basically, this itself
It's like I'm chasing the sun, and all my fears are on the run. Can't take my freedom, now you can take my freedom. It's like I'm
this itself is a tetrahedron, or also known as a 4-simplex. If we go with 2 rolls, this is where it gets a little more complicated. So, there is the possibility that you rolled both 1 and 1. There is the possibility that you rolled 2 and 2. There is the possibility you rolled 3 and 3. There is the possibility you rolled 4 and 4. There's the possibility you rolled a 4 and a 1, a 4 and a 3, a 4 and a 2, a 1 and a 2, a 1 and a 3, or a 4 and a 3. Alright, those are all possibilities. And if you rolled a 1 and a 2, in what order did you roll them? There are 2 ways to get there. Either a 1 and a 2 or a 2 and a 1. So they count double because there are 2 different ways to get there. Now this is also a 4-simplex. However, it ends up being that you have these stops along the way, which are also are 2s. Right? All of the cases in which you have 2 different ways to get to that particular point. If you have 3 rolls, this is where it gets complicated. Right? We have the possibility that you rolled three 1s, 2s, 3s, and 4s. Right? There's the possibility that you rolled 3 of any one of those. How many ways does that happen? 1. You rolled a 1 and a 1 and a 1. That's the only case. Right? What about what happens when you roll a combination of 1s and 2s? Well, it could be a 1, 2, 1, 1, nope, not yet. A 1, 1, 2, or a 2, 1, 1, if you rolled 2 1s and 1 2. Okay, so there are 3 different ways to get there. And then also to roll 2 2s and 1 1, then it's 1 2 2, 2 1 2, and 2 2 1. There's also 3. And that's the same for any of these numbers. So, how many ways are there in which you can roll any one of these combinations of 1s and 2s and 3s and 4s? Well, there's one way to get all 1s or 2s or 3s or 4s. There are 3 ways to get 2 of one and 1 of the other. But we're missing a case. Right? In how many different ways can you get 3 of those 4 to show up, right? 3 rolls. So in how many different ways can we get 3 of those numbers, there are 4 numbers, to show up? Now you should recognize the words for this, right? You probably have vocabulary for it. Might be hiding, but you've got vocabulary for it. There is a 1 2 3, 1 2 4, a 1 3 4, and a 2 3 4. And then the number of ways in which those could occur. I think this is less complicated. So another way to do this is to look at the previous setup and say, like, okay, if we're in any one of these cases, how many ways are there to get the following? And so if we're in a state on one of the 4 corners, then we've already got 2 of one of the numbers. So we're not going to end up getting all unique numbers. It's not possible. So we can discount those entirely. The only places that we can get to having 1 of 3 of the 4 numbers is if we're on one of these 2s. Right? If we got, again, a 1 and a 2, a 1 and a 3, a 1 and a 4. 2 and a 3, 2 and a 4, etc. So this means that in order to get to having 3 different numbers, each of these 2s has only 1 number that's missing. But it can be either of the other 2 numbers. There we go. Okay, so each of these has 2 different possibilities that will accept and get us a new set. So our 1 and 2 can end up being either a 3 or a 4. Right, and a 1 and a 3 could either be a 2 or a 4 in order to get unique numbers. So the different ways in which this could occur is going to add up to, and this is where it gets a little crazy, it's going to add up to 24. Because we've got 2 ways to get here, and then 2 more ways to get to having 3 of the total numbers. And then the same here, and the same here, and the same here, and the same here, and the same here. So 2, 4, 6, 8, 10, 12 by 2 is going to get us 24 different ways in which this could connect appropriately. Could have started with an easier one. It's fine. Right, so if we wanted to go with 3 rolls, we want to know what the probability is of right, number of 1s, 2s, 3s, and 4s. Right, we've had 3 rolls. So 2 1s, no 2s, and a 3. Right, what is the probability of this occurring? Well, what we need is that there are 2 P1s. So the independence of this probability is going to tell us that no matter when we pick up the P1, it always has the same probability, P1. And we're going to have no P2s, or no 2s. We're going to have 1, 3, and we're going to have no 4s. Then the number of ways to get to that state again, we could have had 2 1s and then a 3. We could have had a 3 then 2 1s. We could have had a 1 and a 3 and then we got another 1. So there are 3 different ways to get there. So this is going to be the probability. Nope, sorry. This is the number of ways or the number of successes that we're going to get based on this. Then we have to divide by total number of cases, which for this is just sum up all these numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 threes. So 12 by 3 plus 4. I did too many there. Oh, no, it's fine. Never mind. Those are crossed in the middle. That's not a 1 behind that 24. 4 by 1 and 1 by 24. So the number of successes that we have, again, it's going to be 3 times whatever P1 squared is going to be by P2. Well, any of the ones that are 0 we could just leave out. P3 to the first. All over. That's going to be 3 times 12 is 36, plus 4 is 40, plus 24 is 64. Which also makes sense, because the number of different possibilities of rolling a 4-sided die to hit 1 or 2 or 3 or 4 has 4 possibilities. You're doing it 3 times. Independence says that it's going to be 4 to the third possibilities, so 64. Right, so the total number of cases, really, are mutually exclusive. Right, you cannot have both 3 ones and also 3 different ones. 3 different numbers on the dice, right? They cannot all be the same and also all be different. It's not possible. So those cases, the total number of cases on the bottom, are mutually exclusive from each other. You've rolled 3 dice. What do the dice say? Whereas the number of successes that we had here each roll is independent of each other. They don't affect the other one's outcome. Whereas here, the individual cases or individual outcomes are mutually exclusive. They cannot happen at the same time. So if you do have a fair die, right, a fair 4-sided die, and I want to just throw this 3 times, then the probability is super easy. Right, the probability of P1 is going to be 1/4, and the probability of 3, or P3, is also going to be 1/4. So that's it. Right, this is fair. Which then, if we take that as written, this is going to be 3 times a quarter squared is going to be 1/16. P3 is going to be 1/4. I already accounted for this. This shorthand is going to be variables. Right. Okay. I changed that because here, this is already going to take all that into account. So this is going to be 3 out of 64. We don't need to divide by 64 again. That was a mistake. Okay. So with this, we get what's called a multinomial. Not polynomial, multinomial. Distribution. Now, I re-derived this probably about 10 years ago. I was like, oh man, this is so cool. Hey, Kyler. How's it going? Yeah, this one works pretty well. Unfortunately, copyright-free music decided to restrict the number of songs they had, or maybe they had to remove a bunch. There are only 45 songs now, and it's only a 2-hour playlist. What am I gonna do? That's all right. So the multinomial distribution is given by the choose formula. So in the one above, we had 3 choose 4. Right? We wanted the number of successes to be 3. Right? So we wanted 2 1s and 1 3. However, n in this case was also equal to 4, which is an important caveat. I don't know what if there's actual notation for it. But essentially what we want is right, the total number of possibilities. So it would be like KCR with n equals 4. The way that this works is we're trying to derive the this particular formula here. Or rather, what is the formula for this polynomial expansion? So normally this would be called like we do a binomial expansion, a plus b to whatever power, and that gets us our usual like Pascal triangle. So if you've ever done the Pascal triangle stuff, that's where this comes from. That's where this leads to, or that is where this comes from. No, I'm wrong. Hang on. This is n. The number of objects that we have is n. Yup. I'm also wrong about this thing then. It's not going to be 24. Crap. We'll come back to that. Right. Probably should have gone with 3 first to remind myself how to do this, but nonetheless. Okay, so n is the dimension that we're working with, i.e. the number of possible choices that we could make. Then that's my other problem. The choose formula does not look like this in higher dimensions. That's my problem. It's case of I choose. R. So what we did was we did 2, 0, 1, 0 as our selection. So the number of choices that we have made. It's not K. This is R. How deep in the pattern are we going? Yeah, sorry, I have to reverse engineer this like every time I do it because it's been a while. Right, so we're raising this polynomial, or this multinomial in this case, to the rth power, because that is how far down we're going. So how many oh. Ew. No, okay. This is an R. This is the sum of the K's. So how many choices are we making going across? In this case, it's 3. In 4 dimensions. Okay. So the number of different possibilities that we could have made was going to be 3 factorial.
Better for the planet. And with a giant 5-year warranty, you'll be printing Hey, I'm recording it.
Over 2 factorial, 0 factorial, 1 factorial, 0 factorial.
Online at WeBuy.com. CEX.
Sometimes creating an ad campaign
Okay,
can
that's
feel
going
like
to
you're
be
talking
6 divided by
Sorry,
2
can't hear you.
times 1 times 1 times 1,
but advertising on
which
Spotify
is
can help
3.
your business turn up the volume. With our easy-to-use ads
Okay,
manager,
we
you
got
can
it now.
create new audio ads from scratch or
Sorry about that.
repurpose existing video assets. Then we'll deliver your
So
ad to
what's
your
happening
audience
here
with
is we're looking for the
and
coefficient
message.
that is going to sit in front of
Your mix at ads.spotify.com.
that particular value. Okay. So if we want gross. If we want that's not going to help. Right, this is going to be super awkward. Because we're basically saying, how many different combinations are there to get 3 different values? So I mean, that's 3 choose 4, just by itself. Which is 4 factorial over 3 factorial 1 factorial. Which is going to be 24 over 6, which is 4. So there are 4 different possibilities for getting 3 different numbers of 4. Now we already did this. It was 1, 2, 3, 1, 2, 4, 1, 3, 4, and 2, 3, 4. And these are in different locations on here, so it's not just 24 stuck in the middle. Ugh. But then, how do we get the... Oh my god. Normally, what I'm looking for is that there should be like a single central number, and then in the next one, it's going to create its own tetrahedron. But I could be wrong. Very likely I'm wrong. In that this one has no central number because we're not balancing anything. Right? We need 4 in order to get a number in the center. Because we would have had a 1, a 2, and a 3, and a 4. And 4 choose 4 ends up being 24. So that one is the one that has 24 in the middle. And then it builds out around it. So there's going to be a 1, 4, 6, 4, 1 pattern all the way around it. This is going to be a little weird, so apologies. 6, 4, 1, 4, 6, 4, 1, 4, 6, 4, 6, 4, 1. Sorry, Darth. This is getting a bit into the weeds. in addition, right, each line is going to be like a multiplier of every line is going to have a multiplier of one of the previous ones. Okay. In between this number and that number, there's going to be another. And in between that number and that number, there's going to be another. But those are going to be the same one. They intersect at the same location, I think. And that one and that one. Right? Is that true? Yes, because if we have a 1, a 2, and a 3, then there's going to be a central number in that particular, on that particular face. So this is going to be a 6, and a 6, and a 6, and a 6 on each of the faces going around. It is also a 1-2-1 pattern multiplied by 3. Over on the 4-roll one, we're going to have a 1-2-1 pattern multiplied by 6. It's going to get us a 12 here, and a 12 here, and a 12 here on each of the faces. And then the 24 in the middle. Yep. Okay. That's what I forgot. There's the possibility of getting a 1, a 2, and a 3. There's 6 different possible ways of getting each of those combinations. 1, 2, 3, 1, 2, 4, 1, 3, 4, and 2, 3, 4, which are the faces of those tetrahedra. Yeah, that's where we get the 24 then. Awesome. So it's not 1 by 24, it's 4 by 6. But it's the same number overall. That's why I was confused. Four by 6. And again, why we still get the same numbers. Why we still get the same percentage. Okay. Sometimes it takes a little time to refamiliarize myself. Okay. Well, anyway. I hope that helps, and it wasn't terribly confusing. If anybody does have any other questions, let me know. I didn't actually copy down the equations for this. That's too bad. Okay, so we get x equals y squared plus 3. And, oops, nope, not that one. That one. And then this is x equals 4y here. and revolve. Revolve around the y-axis. Okay, so what we do is we're going to build a rectangle this way, and we're going to say that this is going to be x equals 4y minus y squared minus 3 plus parentheses plus 3 as our x value, the distance that we get in the x direction. The distance we get in the y direction is going to be delta y. And so the volume of any particular, it is not a, no, this one's a washer, right? Any individual slice of any individual washer is going to be pi times r squared. R equals x. And again, it's the difference in the squares of the radii that'll get us the washer method. So this is going to be 4y squared minus parentheses y squared plus 3 parentheses squared. And then put i's next to all the y's, because we can make all these things different. Okay, then we want the sum of all of them as I goes from 1 to n. Pi times the sum as I goes from 1 to n of parentheses 4 y sub I parentheses squared minus parentheses y sub I squared plus 3 parentheses squared times delta y sub I. Take the limit as n goes to infinity of all that stuff. Again, same as above. And that's going to get us the total volume equal to pi times the integral of. We're going from a y value of 0 to a y value where they're equal to each other. Y squared plus 3 is equal to 4y, so therefore y squared minus 4y is, nope, plus 3 is equal to 0. So this is going to be y minus 3, y minus 1 equals 0. That is not correct. Oh no, it is. I just wrote it wrong. It's fine. We will. Okay. We will rewrite the axes. Okay. If this is plus 3. Nope. It's not going to happen there either. Okay. So this is plus 3, which means that we get something that's more like out here. And it's going around the axis there, which means... gross. You know what? No. You know what? We have a line tool. Let's use the line tool. And then reduce sloppiness. Okay. And then we've got the other side of it going this way. Something like that. Sure. You know what? It's close. Okay, so that point there, which is then going to be sent along here. Okay. Good. I think we're good. Either way, washer method. We have these going. We have the limits of integration going from a y value of, so this was correct. Y is going to be equal to either 1 or 3. And then what are those values? So if y is 1, x is 4. If y is 3, x is going to be 12. Right? And those are linked to each other. So it has to work that way. So our y value is going to go from 1 to 3. Of 4y parentheses squared minus y squared plus 3 parentheses squared dy. Whew. V is going to be equal to. Adds are going to start in less than a minute. This is 16y squared, which is going to end up being 16 over 3y cubed. Again, it needs a 3 in order to take the antiderivative, so we need a 1/3 to balance it out. Minus. That's not going to be polite. Because the interior needs a 2y as its derivative, or 2y dy. We only have a dy, so we're going to have to expand this whole thing out. So this is going to be y to the 4th plus 2 times 3 times y squared is 6y squared plus 9. And then that is going to have its derivative taken, and it's a minus all of that. Okay, taking an ad break. Be right back. 3 minutes.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can
Okay,
create new
so
audio ads from scratch or repurpose
I was doing the Tai Chi form a little bit more today. Rather than doing the split elbow shoulder thing, I'm learning the actual form now. So basically we start from a fairly neutral position, feet are more or less together, and then from here we sink into what's called the inguinal crease, which is this the place on your the interior of your hip where your midsection and your thigh kind of come together. So a lot of times you end up putting more of a crease in there in order to use the muscle that's immediately surrounding it to burst out of it in order to give yourself more power. So the initial part of this is that we're just kind of standing in a neutral position. Feet are more or less together. We sink into the inguinal crease here and then step out into bear. So you remember from all of our warm-ups when we were doing this stuff, we were going to this bear position here. Then we kind of sink into this, come back the other way, put almost all of our weight on the left side in order to shift our right foot around and carry the energy ball around to the front, where we take the heel of our foot and drive, which causes us to move kind of even more forward. Now that we're mostly on our front foot, we take this and we step out with the left foot, come forward with a ward off, and then the right hand kind of stops about here, pretty close to our thigh. And then that also requires a right leg shift. Then we're going to it's going to sink again to the left, which then allows us to bring these across each other in order to get to a ward off position with the right hand side here. And then we again bring everything forward by stepping on our heel on the left foot, which gets us to this position. Now we do the standard thing that I've been doing all along, which is we kind of come to the right, sink into the front inguinal crease here, point hand to the mid forearm, do a rollback, go to about 45 degrees. We're shifting all of our weight to the back foot again, sink into that inguinal crease, bring the other hand around, match up with the heel of the palm, and press forward. That's our press. Come apart, come back, and then push again. So very similar to how we did all of our forms before, or the form before. That's where we end up. Now the form, the actual form, the one that's not just a showcase of all 8 strikes and whatever, starts from here. We sink, we sink back. After we do our push, we sink back and turn our turn our right heel 90 degrees until, this is very awkward, our left foot is pointed 45 degrees this way and our right foot is pointed 90 degrees this way. So this is what people call pigeon-toed. So we're in this super awkward position. We've just come from here. We sink back. We take our hands And as we turn our foot, we just turn the whole body this way. Then, as we come around, we sink into this inguinal crease, come around this way, put our hand as like a little duck mouth in this hand over here, and then what we're going to do is kind of snap around on our heel here with our left foot, and also strike out with what's called a single whip. So you're striking out with the wrist on your right hand. So from here, we've come around this corner, we go to here, and then we kind of pop out like this. And then our left hand, whether it's here or here, I don't remember exactly. It's fine. It's been a day. We take this and we take a large step out, and at the same time bring our hand out coming toward us. Then we take our weight, shift it forward, at the same time take the right heel and come out to the 45-degree mark, and also turn our hand this way. So that's like a whole bunch of moves at the same time. Right, so we're 45 degrees that way, we're 90 degrees that way. Right, awkward. Come this way. Then, again, cycle around into the inguinal crease. Come this way, back around, and whip. And then we take this hand out, shift weight, flip hand, and move your heel at the same, or pivot on the heel at the same time. So now we're here. We bring everything in, and then we prepare to move this way. Basically, all of the weight is now on our back foot. Almost nothing's on our front foot. We've got our heel barely touching the ground. And this is 90 degrees. Heel is pretty much aligned with the other heel. And our hands come up like this, and we're in a, here. And we're in a ready position to like parry all sorts of crazy stuff that's coming at us. And that is as far as I've gotten on that particular form. I am going to study this over the next week. We're going to do a lot more like inguinal crease stuff so that we can pop out of it and have like actual power. And next Wednesday, I'm hoping to impress my instructor. Interestingly enough, I saw when we were playing Nine Souls last night, I actually did see Yi, our Tai Chi kitty. I did see Yi end up here in the single whip. So when he's doing his unbounded counter, he comes around and does a single whip. And I was like, somebody on the animation team knows Tai Chi. Yes, Poison Mouse. So I have done Tai Chi for the last year. Eskrima is the one with the sticks. So I do enjoy a bit of eskrima, but not today. You only do Thai bed? Yeah. Taekwondo, karate, and judo. Nice. When you get down to it, like all three of those are very heavily striking. Because I did Tang Sudo for 17 years. Like that's very much in the same vein. It's all striking. So we were talking about this today, me and my instructor, because everything is heavily heavily focused on striking, there's not a lot of like, I mean, there's some blocking, but like, you're kind of blocking incidentally. Or you're blocking as a strike, like you're coming up and smacking it out of the way. With Tai Chi, it's actually very interesting. One of the things that I don't have a lot of leeway, but I have some. Like the way that we were doing this was you've kind of got your hands out here, and you're already in this sunken back position, and then when somebody comes at you, you basically just throw your hands up like this and get either into this position here where you're on your back foot, or you come forward on your front foot and you're here. We did some partner work this last Saturday, where this guy was like trying to punch me. I mean, not really, but you know, practice punch. Just come straight out. And we would both come in like this and do that simple blocking mechanism. And it ended up being like, okay, you could block the hand that's coming. You could block the hand that's coming and then swat it out of the way, get it with the other hand, and then do something. So it was like 1, 2, 3, 1, 2, 3, 1, 2, 3, and it worked out really well. So I actually can't wait to go. Asterisk. Yeah, go away movement. The I probably know more than you and you don't want to continue this movement. So we did the partner work, and like I said, it worked out pretty well. We were both getting inside, doing like a quick parry, a cross grab, so that you would control their arm, and then a third hand would be able to strike. So it worked out pretty interestingly. It did not quite work out 100% because at one point I came in with a haymaker, and he was like, "Oh shit!" Ah. I was like, "I'm sorry, I'm just being an asshole. It's all right." It was like, "Oh, we're just gonna do straight punches. We're just gonna do straight punches." Ah, haymaker. Alright, and we also did redeem one times hot stuff coming through. Alright, Poison Mouse. You may want to stick around just long enough to see whether this is a dud or not. It has a good color to it, so it should be alright. This is a Japones hot pepper. And we have not much water, although honestly, you don't want water when you're doing these. So we'll see how this goes. Oh, yep, that's a nice one. The last one I had, I think, was one of these. Ooh. Which has had like all of its color sapped out of it. And it was a complete dud. That's a good one. Oh. Mistake. Now it's just spread around evenly. Oh, that was a good one. So we also have the pekin or pekino peppers, which are these little ones, which are rated an 8.5 on the hot scale. I believe these are rated a 6. Oh.
With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
Not why. 3 to the 5th minus 1. Whew. Alright, this is 27 minus 1 is going to be 26. Minus, parentheses. Whew. 3 to the 4th is 81. 3 to the 5th is 243. Minus 1 is 242. Plus 2 times the 26 that we had. Interestingly, right? That's going to combine with that pretty nicely. Plus 9 times 2. Pi times 2 is 6 over 3, which is going to be 10 thirds. 26. Minus 242 over 5. minus. Right, this was a, keep in mind, right, minus 2 and minus 18. Undo. Bracket. I also do hot peppers for payment. I have restricted it, I believe, to 2 a night. 1 through... Thank you, Famish. 1 through points and 1 through payment. So if anybody feels like torturing me again, I don't know, it might be $10 or something like that. Oh.
Shame. Shame. Shame.
But why would you want to pay for it when you can just do other fun stuff for free? Alright, minus. Oh. 18 is 60. Nope. 80 over 5. Nope, that's 90. Oh. 90 over 5. Das Lewin hoist. Yep. Oh. Alright, let's get the glove off, because that's going to be distracting otherwise. Oh, man. Hurts. Hurts so bad. And I think I got a piece of hot pepper stuck in my tooth. Oh, that's gonna stick with me for a while. Okay, we're about there. Drop one. Gently. And triceps with the other. Around the cord. So we don't get caught. Oh, hey, we're back up to 690 followers. Awesome. Next question. When did that happen? Because I don't think anybody followed me tonight. Now, good news. Didn't actually hurt. But let's keep it away from my head a little bit more. Alright. Thank you, Famish. Oh. Ah, man. No. Okay, 698. Right. That was... That's what we had the other day. Right, never mind. We're good. Hot pepper. Oh, man. Like I said, this is only a Japones hot pepper. It's not that hot. It was like a 6 or maybe 7, I guess, on the rating scale. That, like, there's this company, Don Enrique, comes out with like a whole line of hot peppers, and then they have a little scale at the top corner that shows you how hot those particular peppers are. The pepino are 8.5 out of 10. Epice. Whereas the Japones are only, like I said, a 6 or a 7, somewhere in there. Oops. No, don't listen. Don't listen. No, don't do that. No. I'm gonna get copyright. Good news is I don't get strikes for it. It's just, like, they mute it. They're like, oh, you want to mute your stream, right? I'm like, man. Whew. All right. Coming off the tail end of that one. So 18 is 90 out of 5, or 90 over 5. Added to 242 is going to be a negative 332 over 5. And then we're going to have to combine those. Oh, man. It's 1,300 out of 15. Pi. 1,300 out of 15. Minus 332 times 3 is going to be a 996 out of 15. So good news there. Pi times 1,300 minus 1,000 is going to be 300 plus 4. It's going to be 304 out of 15. That is not divisible by 3 or 5. So that is it. 304 out of 15 pi. No, sorry. 304 pi over 15, or 304 out of 15 pi. So, yes, that is what we got on this thing. Awesome. Famish, did you see the Tai Chi? I forget. How's it going, Phobos? I'm sorry, I saw your name in there and it just completely, like, I was not paying attention. I got lost in a conversation with Poison Mouse. Good times. I torture myself, but it's fun. Yeah. So that's what we got here. Okay. So. The next question is, how do we do arc length? Gross. If anybody has any questions on stuff we've done so far, oh, right, we didn't do the other one. What happens when we just take, like, a generalized, I mean, not literally a generalized one, but let's take this one that's here. Gonna do some gaming, but you gotta clean your work area. Oh, always the worst. I've got so much dust, like, up here and down in my towers that, like, I need to actually, you know, run a vacuum off in the air and then just, like, start smacking, not really, but start, like, dusting out the towers such that all of the dust then makes it up to the vacuum. Okay, let's use this one actually. So this is y equals x squared going from 1 to 2. And we're going to do something weird, which is we're not going to rotate it around the x-axis. Instead, what we're going to do is we're going to rotate it around y equals -1. No, x equals -1. Okay. So we want to take this thing that's bounded by the x-axis oh no, we haven't done that one yet. That's okay, we'll do it anyway, because there's a strategy. Right, so we're going to we're going to find the volume of a solid that's taking this, again, y equals x squared, and then going to go around x equals -1. So the first thing that we can do is the obvious thing, which is if we just take a block here, right? This is its own rectangle. Therefore, it will make its own washer going around the axis. So the axis of revolution is now going to be x equals -1. So what we do is we say volume for the individual rectangle, it's totally a rectangle, is going to be equal to, this is going to be pi times r is going to be the far bit, so that's 2. Oh, no, it isn't. Okay, so this is going to be 2 minus, right, from 2 all the way back to -1. So we know that that distance is 3. But you want to be able to prove this or do it in a more generalized case. So it's from 2 to -1, so 2 minus -1 squared. So this is going to be 3 squared, which is 9, minus the closer value, which is going to be now 1 minus -1 parentheses squared. So pi r squared, or in this case r1 minus r2, r1 squared minus r2 squared. That's how we end up getting these things. This is a 2 squared. So it's 9 minus 4. It's going to end up being 5 pi. Okay, plus the bit on the top. Right, how do we get this one? Right, volume I rectangle plus curve bit. Okay, so radius 1, again here we need a pi, times radius 1 squared minus radius 2 squared. So radius 1 is going to be same thing as before, 2 minus -1 squared minus, this is only going to go as far as y equals x squared, which because we're doing this in terms of x as a function of y, we have to go backwards. So this thing, right? This thing is x equals square root of y in the positive direction. So here, this is going to be square root of x, parentheses, square, nope, hang on, right? Because we have to now, it's the square root of x minus -1 squared. Because we have an extra space in between these pieces. So this is now going to be pi times 2 minus -1 is going to be 3. That's 3 squared again, so that's 9 again. Minus okay, so minus parentheses. This is going to be square root of x times square root of x is just going to be x. Then you get it's square root of x plus 1. So this is going to be 2 square roots of x. Okay, and then plus 1. And this is x sub I in these individual locations. The rest of it's just constants, so like we don't have to worry too much about it. Alright, so v sub I is going to be equal to 5 pi plus 9 pi minus pi times the quantity, x sub I plus 2 root x sub I plus 1. So any individual one is going to have that. The sum total of all v sub I is going to be equal to 14 pi minus 1 pi. So that's going to be 13 pi. Minus pi times x sub I plus 2 root x sub I, summed as I goes from 1 to n, and then the limit as n goes to infinity of the sum of I goes from 1 to n of v sub I is going to be equal to the sum, god damn it, the sum as I goes from 1 to n, limited as n goes to infinity, for 13 pi minus pi, parentheses, x sub I plus 2 root x sub I, okay, is going to be equal to, this is the integral of 13 pi minus pi times the quantity, x plus 2 root x, 2 root x dx. Right, I forgot. We need a delta x in here, sub I. If we do all this, delta x sub I, sure, times delta x sub I times, no, that's it, right, dx. And then we're always going, in this case, from 1 to 2. So we did have this extra space to get from where we wanted out to x equals -1. But that's what we got. The volume's going to be that. So the volume's going to be equal to, this is 13 pi x going from 2 to 1, 1 to 2, minus 1/2 or pi over 2x squared minus 2 pi times, this is x to the 1/2. It's going to increase to x to the 3/2, and then we have to divide by the new constant, which makes it 2/3 times that. And then those are each evaluated from 1 to 2. Alright, volume is equal to 13 pi times 2 minus 1. Linear. Nice and easy. Minus pi over 2 times, this is going to be 2 squared minus 1 squared. Right? 4 minus 1 is going to be 3. So this is minus 3 pi over 2 on the next layer. This is going to be, 2 minus 1 is 1, so 13 pi. We don't have a deficit here. No worries. This one is going to be minus, this is 4 pi over 3 times the quantity, 2 to the 3/2 minus 1 to the 3/2, which is just going to be 1 again. So this is going to be a minus 2 to the 3/2 is going to be the square root of 8, which is 2 root 2. So this is going to be 8 pi root 2 over 3 plus 1 times 4 pi over 3. Okay, V equals. And I don't have any sort of computer that's going to help me on this one, but we can kind of use intuition to figure it out. Sort of. We could do over 6, which is going to make this 60, 78 over 6. Minus 9 pi over 6. Minus twice that is 16 pi root 2 over 6 plus 8 pi over 6. Okay, this is going to go away with all that, so we get a minus 1 pi over 6. uh, 78 minus 1, so 77. And then minus 16 root 2 pi's on 6. (16 root 2 is 1.4. So that's going to be a 6.4 plus 16 is a 22.4 roughly. 22.4 off of 77 is going to be 54 point. What did I say? 54.6. 54.6 times pi over 6, which is roughly speaking a half. So if we wanted to keep this estimation going, right, it's 54.6 divided by 2 is going to be a 27.3, give or take. I'm actually curious whether how interesting. I don't know how to feel about that. In Britain, jury trials have now been scrapped for crimes with sentences of less than 3 years. I mean, I'm not doing any crimes, but... Whew. Okay, Wolfram. Alright, find the volume of the revolution of, no, of the solid revolved bounded by y equals x squared and the x-axis x equals 1, x equals 2, revolved around x equals -1. You jerks. It did not find what I asked for. Interpreting as volume, solid, assuming solid is a class of elements. Use as referring to chemical compounds instead. Input interpretation, solid elements at standard temperature and pressure, atomic volume. Summary, median 1.56 times 10 to the 7th picometers cubed. Nope. Not even remotely close. Calculate. Let's just try to change it ever so slightly and see if that... Nope. Still does the same thing. Calculate... How about just calculate the volume bounded by the following? Wolfram Alpha doesn't understand your query. From calculus 2, do the following. You're not going to know what I want. Nah. Boo. Alright, so let's do this as math input. So let's do it as this and see if we get the same thing. We should. Go from 1 to 2 of 13 pi minus, no, pi times, actually, you know what, let's just do 13 minus, should be off by a factor of pi, parentheses, x plus square root, no, there's a symbol for that, let's use it, square root of 2, no, 2 square roots of x. Nope. Nope, don't do that. Nope, what the... Okay. Gross. dx. Yep. See it. Okay, says that it's going to be 77 over 6 minus 8 root 2 over 3 or 16 root 2 over 6. 16 root 2 all over 6 times pi. 77 minus, nice. So we did get the exact same value here as Wolfram, although to be fair, it figured it out from, you know, here, which is pretty much the same. I'm pretty confident with my algebraic abilities. The question is whether or not I got this set up correctly, which I'm pretty sure I did. Okay, so what's actually happening, just as a reminder, is that we are setting up a rectangle here like this. We're saying that this difference here is going to be not d, delta y sub I, and then the horizontal distance here is going to be 2 minus, again, it's not 2, it's 2 minus negative 1, as in we're going to go from here all the way out to here. So what's that distance? That's our radius. That's going to be squared. Right, never mind. That's... in the linear sense, it doesn't change. So if we were to do, okay, it's 2... it won't matter, right? If we're just doing it linearly, it won't matter. Because we're looking at what's the difference between 2 and this function and 2... nope, this function and 0. So like 2 minus f minus negative 1. So essentially it ends up being 2 minus negative 1 as like an overall thing, if we were to do it linearly. But then, when we notice that we need to do it as a volume, this is by the square. So we have to be really careful about that. Okay. So yeah, this would end up being
When your kid's favorite toy starts to run out of
right.
battery
The
power,
distance between any two numbers is going to be the same regardless of where you put the 0 point. So that's not going to matter at all.
it's on Prime.
Right. Cool.
Times and T's and C's apply. See
We don't have to worry about it then. Okay, this is going to be xy here. Okay. Good times. Okay. I'm going to take a quick break. It's going to be a standard 3-minute ad break, and then we'll be back. We'll do Arclength and probably call it for the night after that. So thank you so much, everybody, for coming. Yeah, Famished, Poison Mouse, Phobostream, Color Cone, Slayer Darth. Hope y'all are having a good evening. And if you have any questions, let me know. Otherwise, I'll be back in 3. And we'll get down to this last section. So 3 minutes, everybody. cheddar cheese sticks. Nom. Just like little pieces of dough that they've spread some cheesy, no, not really garlic, just cheesy butter or something like that on it. And then twisted them and baked them. Quite good. All right. Typical thing happens when you're talking about arc length. So what we're going to do first is ensure that we have all of the pieces like we did in the previous section. Right? If I want to take any two random positions and just be like, okay, look, they can be any distance apart. It doesn't actually matter. But how do we find distance between 2 points? Well, this is going to be the distance formula, which we all pretty much know as the Pythagorean theorem. So here, d sub I can be approximated by this dy here. And that, no, don't do that. This delta y here and this delta x here sub I. So what does that mean? Well, that means that d sub I squared is going to be equal to delta y sub I, parentheses squared, plus delta x sub I squared. Which means that d sub I is going to be, equal enough anyway. Approximately equal to square root of, right, delta y sub I squared plus delta x sub I squared. Then right, d sub I is going to be approximately equal to if we factor a delta x sub I squared out, we would be left with a delta y sub I over delta x sub I, parentheses squared, plus 1. And then that delta x sub I squared can come out. So we get d sub I is approximately equal to the square root of delta y sub I over delta x sub I, parentheses squared, plus 1. Okay, times delta x sub I. Right? So now we could say, okay, take the limit as n No, wait, hang on. Take the sum of all d sub I, as I goes from 1 to n. Right, same here. And then we take the limit as n goes to infinity of this d sub I. It's going to be equal to the limit as n goes to infinity of the summation of the square root of times delta x sub I at the end. Again, here this is delta y over delta x parentheses squared plus 1, and i's on those as well. I goes from 1 to n. Which is going to be the distance overall is going to be equal to the integral from a to b of the square root of dy dx parentheses squared plus 1 times dx. Now, here's the other thing about this. A to b, square root of dy dx is just f prime of your particular function, and yeah, it can be of, you could do it in terms of y as well, but you'd have to work through it. Right, so f prime of x squared plus 1 dx. Right, this is one of the problems with arc length problems, is that many of them end up being not very nice integrals, and you don't want to have to deal with them. It is possible that you could find a nice integral to make it into something better, but I don't want to, like, generally throw it out there and just be like, oh yeah, no problem. Like, okay, so here, what is the length of the curve? Bounded by y equals cube root of x cubed, no, sorry, square root of x cubed, where x is going from 0 to 28. Okay. Okay, so this says that our y prime is going to end up being, this is a 1/2 x to the 1/2 so I was wrong, right. Okay, so if we played by the kind of rules that we learned in class, right, this would end up being a 1/2 x cubed times the derivative of x cubed, which is 3x squared. Oops, hang on. This raised to the negative 1/2 power. There we go.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry.
half comes down. We end up with negative a half up top. X cubed is still there. Then it's times the derivative of the inside is 3x squared. That is a negative 3 halves. This is going to be x to the positive 1 half times 3 halves. Cool. Verification. So you do want to do it kind of two different ways if you can make sure. Okay? So, the length of the curve, distance, is equal to distance is going to end up being 3 halves x to the 1 half parentheses squared plus 1. From 0 to 28. Oh my goodness. And dx. D is equal to... nope. Okay, this is 3 halves x to the 1 half, parentheses 2 plus 1, all raised to the negative 1 half, times 9/4 x. So we take the derivative. Nine-fourths that's equal to, that's not the next, oh man. It's not multiplied. So this is going to be, if we take the derivative of it doesn't work. Right, so 3 halves times x to the 1 half, all squared. X to the 1 half can become x, not 3 halves is squared 9/4. Okay, 9/4 x plus 1. And dx. Okay, we need 9/4, which means we need to balance by 4/9. also need a 3/2. Okay, so 3/2 would come down from the top and become raised to the 1/2, which is what we got here. Then we need to also multiply by 2/3 in order to balance that. So this is going to be 8/27. Taking the square root of, or taking the root of all that stuff, we still get 9/4 x plus 1, but this time it's raised to the 3/2 power. And that's going to be evaluated from 0 to 28. Right. 8/27 multiplied by, this is now going to be 9/4 parentheses 28 minus 0 plus 1 to the 3/2. 8/27. This is going to be 28 divided by 4 is 7 times 9 is 63 plus 1 is going to be 64 raised to the 3/2 power. Square root is going to be 8. Cubed is going to be 2 to the 9th, which is 512. 8 times 512 over 27. It's going to be 4,900. Nope. 4,096. Oh, nope, not quite. So close. Oh, yeah, okay, no. Because that is not linear. This is not linear, so we can't do that. Okay, minus 8/27 times 9/4 times 0 plus 1, so 3/2. Right? So 8/27 times, again, 28 divided by 4 is 7, times 9 is 63, plus 1 is 64, so 3/2 minus 8/27, and that's just 1, is equal to, again, 64 square root, and then raise it to the next power is 512 times 8 is 4096. So 4096 over 27 minus 8/27 is 4,088/27. Yep. Awesome. Righto. Does anyone have any particular questions that they would like to see in terms of mathematics? If not, we may go over and see what Dr. Gold is up to, because he's doing crazy stuff right now. He's doing a 24-hour stream, probably over by now. Is it? I don't know. I didn't even look. What do we got? Ah, yeah, he's offline. Okay. He's probably sleeping the sleep of the necessary restful. think there is somebody who's online for math, but he's out in India and don't know him. Alejandro's on. Nice. He unfortunately does only speak Spanish, so that's kind of limiting my experience. Alright, let's go say hi to... I'm of 10 minds. We are Legion. Being torn in like eight different directions. It's fine. Let's go see Solu. He's a friend of ours from Nova Scotia. His family's originally from Puerto Rico, and he's been hanging out with his spouse up in... oh no. He's doing Mass Effect 2. Dr. Chakwas just did a dance. So we're going to head over there. Hope I will see you all on Friday for more Against the Storm asterisk. We'll see how things are going. And, yeah, maybe we'll also help plan some of the not D&D session that I'm doing on Sunday. See how it goes. Hope you all have a good couple of days, and we'll see you then. My name's Obi-Wan Pez. This is N Simplex Pachenko. Catch you next time.